let's start today about corrosion. This is the last topic now, corrosion and rancidity. है ना? So, do you know what is this? Just a second. What is this? Do you know? Huh?
Rust.
Yes, rusting. है ना? So, what is corrosion? See, if we kept a metal in an open space like terrace or wherever, then what happened? In air, there is a water molecule. है ना? In air, there is a water molecule. And in air, there is a water molecule in the form of humidity. So the water molecule or the oxygen gas which is present in the environment will start reacting with my metal. This is my metal. This is also my metal. This is also my metal. They'll start reacting with my metal, है ना? Not inside, only in the this covering part, है ना? So what will happen when the surface of my metal will start reacting? So they will start forming a rust on the upper layer. So this whole process is known as corrosion. है ना? Yes, it's a slow process. We can say that it's a slow process. It's a slow process of eating away of metal. By what? By the reaction of atmospheric air and moisture. Rotoniel, understood this part? That how corrosion is happening? Will you please now explain me? Am I audible? Hello, will you please explain?
Yes, ma'am. The moisture basically reacts with the metal.
In air, there is a water molecule. है ना? The water molecule is there in the form of what? Humidity. So the water molecule or the oxygen gas which is present, they'll start reacting with my metal. Because my metal is kept outside acid, so they'll start reacting with it. So they start forming a rust, not inside my metal, not inside, only in the upper layer, the outer covering. So that's the whole process is known as corrosion. Okay, and this is the definition. It's a slow process of eating away of metal. It's a process of eating away of metal by the reaction of atmospheric air and moisture. Means air and humidity or water molecule is eating my metal. So this is a slow process, and this process is known as corrosion. Okay, and here we can say the example of corrosion is rusting of iron, है ना? Rusting of iron, tarnishing of silver, formation of green coating over copper. See, this is my metal. This is my iron. Hello, Shazan.
Yes, ma'am.
This is okay. See, and one more key, formation of green coating over copper, etc. Okay. So, Shazan, you will be here only. It's 10th, no?
Ma'am, I'm in both class 9 and 10.
Oh, okay. So, see, I'm teaching about corrosion and rancidity. Okay. This is the corrosion. What is corrosion, Shazan? Any idea?
Ma'am, I literally have no idea. Ma'am, maybe it's a change in.
See, what happened if we kept a metal in an open space, okay, like in terrace or wherever, then what will happen? The air, in air, there is a water molecule in the form of humidity. In the form of humidity. So the water molecule or any oxygen gas which is present in the atmosphere will start reacting with my metal. Not inside the metal, only in the outside covering of my metal. So they will start forming a rust. So this whole process is known as corrosion. This is the definition of corrosion. It's a slow process of eating away of metal by the reaction of atmospheric air and moisture. Means when atmospheric air and moisture will react with my metal, they'll start eating my metal. That's why there is a rust. See, this is a rust. This is a rust. Some chocolate type of covering is known as rust. Okay. Examples are this: rusting of iron, tarnishing of silver, formation of green coating over copper. Now, see, it's a slow process. It's not an instant process. Okay, and this is the process we call it. Say like we can say my metal is corroded. My metal is corroded. Okay, Shazan.
Yes, ma'am.
It's easy now, and the process is called rusting, and the brown one is known as rust. You know this rust. Now. See, corrosion of iron is known as rusting, but this is what? This is the corrosion of copper. This is not rusting. And see, the corrosion of iron is of chocolate color, but this is the corrosion of copper, which is of Green color. Why this is because of green color, Rosonian? Any idea?
Like fungus.
Huh?
Fungus.
Fungus. Yes, and because also it will react with no copper carbonate. That's why its color is green. It will react with copper carbonate. CC. Okay. Copper. Okay, let me write. Copper carbonate. Okay. And what is the formula for rust? Formula for rust. Any idea? Hello, Rushi. Sorry, Rushil. Any idea what is formula of rust?
Is it Fe2O3?
Yes, Fe2O3
plus H2.
H2O. Okay, this is the formula for of rust. This XH2O because depend on the water molecule.
I mean, it is multiplied by XH2O or plus?
No, multiply.
Okay.
Dot. Okay, depend on the water molecule. Depend on the water molecule. And with different metal like copper, will not use the word rust. We will simply call it corrosion. Only for iron we call rust, but for different metals like copper, silver, we don't call this term rust. We only call normal corrosion. Only for iron we call rust. Okay, see, copper will change its color to green because of the copper carbonate, and the silver will change itself in color black because of silver will change its color to black because of silver sulfide. Okay. Hello, Rushil, because of silver sulfide. Okay. Any doubt till this much?
What will be the chemical formula for that?
For rust?
No, for the other corrosion.
For the corrosion, this is only the formula. Fe2O3 into dot XH2O. And this is
for silver and copper.
For silver and copper. Okay. I'll tell you later. First, let me just go through all do this. Okay. And Rushil?
Yes, ma'am.
Yes. So here I'm teaching about the corrosion. Okay. Do you know what is corrosion?
It's like the red or the color just fades from the metallic substances.
And
Like the
why?
outer scale.
Why?
Because of exposure to water vapor.
Water molecule.
Water molecules.
In air, there's a water molecule, in the form of humidity. So what will happen? Water molecule also we can say, or any oxygen gas we can say, the which is present in the atmosphere, they'll start reacting with my metal. Okay.
Yes, ma'am.
And then the surface of my metal will start reacting. So the surface of metal will start having the rust on the outer covering. So this the whole process is known as corrosion. Only for the iron we use this word rusting, but for the silver and the copper we don't use the word rusting. We only use the word corrosion. Okay. Now, and see, in silver jewelry also we see now that it becomes black after 1 or 2 years later because the reactivity of silver is very slow. Silver reactivity is very slow. Okay, just a second. Yes. So you have seen that now. Our mother go to the jewelry shop and ask shopkeeper to again do this shining in my silver jewelry. So the shopkeeper remove this sulfide part from our silver jewelry, and then again my silver jewelry starts shining. Okay, we all have seen that the silver is there and it forms some black outer covering because of the sulfide part. Okay. So the shopkeeper removes what? The sulfide part from the silver, and again my silver starts shining. Okay, Shazan? Okay. So let me. And that what anyone was asking now, the formula for what? The formula, this is the formula of what? The rust and the formula of silver. Let me write here. Formula of the silver part, the silver and the copper one. So the copper one is CuS plus H2O. It will react with the water. The copper will react with water and form Cu2O plus H2. This is for.
What is the formula for
copper?
Copper, okay.
And for silver,
ma'am, can you actually tell the ma'am, it's the symbol. All of them are symbol. Ma'am, can you just tell it in the
this is the copper, water, and what is this? Anyone? Come on, tell me. Anybody? Nobody knows?
Is it copper oxide?
Yes. And this is for the silver. It will react with H2S. And what is H2S? What is H2S?
Hydrogen sulfide.
Yes. Good. Can you please switch on your camera? Okay. Now, this is what? Anybody? Any idea? This is what? This is our food, and this is sandwich. So this is what? Rancidity, right? Rancidity. Now, See, metal can easily donate electron. Metal is having this property of easily donating electron. This is the property of metal. Metal can easily donate electron. When metal kept in air there is a oxygen or water molecules. We can say oxygen will say that I want a person like who wants me to donate a electron. So in air, so in our surrounding we have kept metal. So metal is there, and metal is having this property of donating electron. So obviously, what will happen? The oxygen will react with my metal because oxygen want electron, and metal can easily donate electron. So the water molecule or the air, oxygen or water molecules. See, the oxygen and water molecule which is present in the environment will say that I want a person like who donate me the electron. And here is the metal. Metal is having a property to donating the electron. So easily they will react with metal because they want electron. Hai na? Yes or no? Shazan,
Yes, ma'am.
yes or no? That metal can easily donate electron. Metal is having this property, and oxygen and water molecules want somebody to donate the electron. So they will see, acha, okay, metal is there, metal can easily donate electrons. So what will happen? They will react with metal. When they will react with metal, then obviously rusting will. Okay, oxygen or water molecule will react with metal. Any doubt here? Corrosion is because of what? Because of metal is having a property of donating electron. If metal will not have the property of donating electron, then corrosion will happen. Then corrosion will happen or not?
Can you show the formula for all of them once again?
What?
Can you show all the formulas once again?
Hmm.
And the first one is for?
This is for rust. Rust means this is for iron. Because iron, this
and
is for
beneath.
copper and the silver.
Okay, great. Yes, ma'am, done.
Okay. So now here. First you guys tell me, if metal will not have the property of donating electron, then corrosion will happen or not? Anybody?
What, ma'am?
If metal will not have this property of donating electron, then corrosion will happen or not?
Ma'am, it will not happen.
It will?
Ma'am, it will not happen. I think.
It will not happen. Yes. Rudronian and Rushil, it will happen or not?
No, ma'am, it won't happen.
And why it will not happen?
Ma'am, because it won't donate electrons. It's because
Because
it's metal.
because it won't donate electron, and oxygen and water molecules want somebody to donate electron, and if the metal is not having this property of donating electron, then obviously corrosion will not happen. And if metal is having the property of donating electron, then obviously corrosion will happen because oxygen want electron and metal is donating electron. So obviously oxygen will react with metal for what? For electron. And if oxygen will react with metal, then the corrosion will happen, then the rusting and all will happen in our metal surface. Okay, anybody, any doubt? No, right? Okay, that ma'am, that student, I don't know his name. Any doubt? Okay, so with silver we call it as tarnishing of silver, and with iron we call it as rusting. With silver we call it as what? We call it as tarnishing. tarnishing. Tarnishing of silver. But with the iron we call it as rusting. Only with iron we call rust, and with the silver we call it as tarnishing of silver. And for the copper we normally call it as corrosion. Okay, any doubt here? This part, this is the theoretical part. Any doubt? Anybody? Anyone? No doubt? Come on, say, speak. Yes or no?
No, ma'am.
No? Okay, chalo. Can we stop the corrosion? Can we stop corrosion?
Yes,
Can
ma'am.
How? How can we stop? Any idea?
By preventing the contact of the metal with the atmosphere.
How come? Rudronial, can we stop the corrosion? Okay. So corrosion of iron can be prevented by covering the surface of metal with paint. We can paint first. Prevented by covering the surface of metal with paint. We can paint our metal with paint or grease or enamel that does not allow air and moisture to come in contact, because this paint, grease and enamel acts as a barrier between the water molecule and the metal. Okay, so that does not allow air and moisture to come in contact with my metal. Okay, so that's the one way we can prevent corrosion. What's the another way? By painting it, greasing it, we can stop the corrosion, because these three things will act as an interface between air molecules, between water molecules, between like oxygen gas and our metal. So the water molecules will not directly come in contact with my metal because paint, grease, and enamel is acting as an interface between the two. Okay. Yes.
Yes, ma'am. Fine.
Right. Chalo. Next. Now, what is the next way to prevent? Anybody? Rusting can also be prevented by only I'm writing prevented. Okay. Prevented by galvanization. And what is galvanization? Anybody? This galvanization. What is galvanization?
The process of coating iron with a layer of some other metal which does not
And
burn,
what
such
is
as
that
zinc.
metal?
Such as zinc.
Yes, zinc coating. Huh? So rusting can be prevented by this galvanization. The zinc metal does not corrode to exposure to air. Zinc metal does not corrode on exposure to what? To air. So we can do a zinc coating in our metal. That's the protection. Zinc coating protection iron from rusting. Zinc itself forms a protective coating of basic zinc carbonate. Okay, let me write. Do you want me to write all this? Huh? Zinc coating protection from what? From rusting. Zinc itself forms a protective coating layer. Zinc itself forms a protective coating of zinc carbonate. If there is a coating of zinc carbonate in my metal, then it will prevent from corrosion. Okay, and what's the formula for this? ZnOH twice dot ZnCO3. This is the formula of zinc carbonate. So zinc is more reactive. Then zinc will say, if you want electron, come and ask with me. Don't touch my metal. So zinc will act as a barrier between a metal and a water molecule. Okay, zinc is more reactive and zinc is having the iron. So obviously zinc will say that come in contact with me if you want the electron, because oxygen and water molecules want electron. That's why they come in contact with the metal. So here zinc is more reactive and zinc is having the electron. That's why zinc will say come in contact with me. I'll give you the electron. Don't go to metal. Zinc will act as a barrier. Okay, I'm writing only this much. Zinc is more reactive. Okay, understood?
Yes, ma'am.
Any doubt, Shazan?
No, ma'am.
No, it's correct only. No, see,
Yes, ma'am.
the zinc is more reactive. So zinc is having the electron properties. That's why zinc will say that come in contact with me. To whom zinc will say? Zinc will say to oxygen water molecule, come in contact with me if you want electron. That's why the oxygen water molecule go and come in contact with the zinc. They won't touch my metal. That's why here corrosion will not happen. Corrosion will be prevented. Okay, everybody. Okay, and what's the third point? Rusting can also be prevented by coating the surface of iron object with chromium, tin, nickel, or aluminium. Only I'm writing coating the surface of iron. Coating the surface of iron object with what? With chromium, tin, nickel, or aluminium. These metals resist corrosion. Okay, these metals, this chromium metal, this chromium, this tin, this nickel, and this aluminium, these are the metals. These metals resist corrosion, hence they protect iron from rusting, and they may be coated by electroplating. Coated by electroplating. Okay, this is the third way we can prevent metal. We can coat the surface of the iron with these metals, the chromium, tin, nickel, and aluminium. With this, the metal will be prevented. Okay, first is by painting it, greasing it. Second is with the process of galvanization, and the third one with the coating the surface with these metals, the chromium, tin, nickel, and aluminium. Okay, and the last way, the fourth way is what? Corrosion can also be prevented by converting the metal like iron into an alloy. Anybody tell me what is alloy?
Alloy is a mixture of two elements.
Elements?
No, not element. It is mix. I forgot.
Oh, okay. Anybody
I'll
else?
tell you, let me refer my notes.
First you can Google it, then you can tell. Okay.
I have notes for this.
Okay, you have notes. Okay, good. Converting into an alloy with chromium and nickel. What is alloy? Anybody?
Ma'am, it's a combination of
An
two
alloy is
metals.
a mixture of two metals.
Yes,
Yes.
two metals. Mixing a mixture of metals with a corroded metal. है ना? Alloy is what? Mixture of two metals. Very good. Mixture of two metals. So this is also the way we can prevent. There are 4 ways to prevent the metal. See, this is my metal. And this is what? This is the copper metal. That's why here green coating is there, na? Because of what? Because it will react with the copper carbonate. That's why the green coating of copper, and for silver there is a black coating, and for iron there is a brownish type of coating. Okay, everybody understood what is rusting and how we can prevent? First, by painting it. Second is galvanization because of the zinc coating we can do. Third is the coating with the surface of iron, chromium, nickel, and aluminium. And third, converting into an alloy. Okay, and here metal can, this is the property of metal, that metal can easily donate electron, and the oxygen and water molecules want electron. That's why they come in contact with the metal, because metal is having the property of donating electron, and that's why they react with it, and then the corrosion and the rusting and all happens. Okay, okay, now let's talk about this rancidity. What is rancidity, anybody? This is the example of this rancidity. This is my sandwich, the fungus. Rancidity, anybody? Nobody?
No, ma'am, I'm in class 9.
Okay, or class. Okay. So, okay, Salo. What is rancidity? When we kept food for 1 or 2 days, what happened? They start oxidizing. They start oxidizing. Rancidity is a process of slow oxidation of oil and fat present in the food material, resulting in the change of smell and taste in them. See, what happened? If we kept food for a longer time outside, then this fungus thing happened now. Shazan, see, this is my sandwich, and this is what? This is the fungus, this is the microorganism. They start developing, start eating my food. So that's the whole process is known as rancidity. And the definition is this. It is the process of slow motion. It is the process of slow oxidation. Slow oxidation of oil and what? Of oil and fat present in the food material. Starts resulting in the change of smell and taste. Smell and taste in that. This is the definition of rancidity. Okay. Now, they also oxidize my food. See, here they are oxidizing my metal, and here they also start oxidizing my food. They're in the corrosion. In corrosion, they here what they do? They oxidize my metal because we are leaving my metal in the surrounding. That's why they start oxidizing my metal. And here, if we are leaving food for 1 or 2 days, they start oxidizing my food also. Okay, the microorganism fungus start developing in my this food surface. This is the example of sandwich. See, here is the fungus in my sandwich. Okay, that's why in packet that's why in this lace type of packet they already wrote the manufacturing. They already wrote the expiry date, that best before the 3 or 6 months. 3 or 6 months manufacturing they already wrote, because after that, what will happen? The rancidity or the microorganism starts eating these chips. Okay. Now now you got the idea of rancidity, Shazan. See, this is the chips packet, the Lays. Here you got 70%. Here you will get the 70% air and only 30% chips. Am I correct? If you guys will buy 20 rupees chips, the green or the blue, any color, then you will see the 70% air is there and only the 30% chips is there.
Yes, ma'am.
Yes. So this air is what? This is the nitrogen gas. This is the nitrogen gas. Here this is the nitrogen gas. Okay. So can we stop rancidity? Like here, can we stop corrosion? Yes, there are the 4 ways to stop corrosion. So can we stop rancidity also? No idea? Yes, we can stop rancidity. How? Keeping food materials in airtight container. See, this is what? Here is my chips. This is very airtightly packed. So if we are keeping our food in a very airtight container, then we can stop the rancidity. Then we can stop the microorganism start developing in my food. Through the airtight container, we can stop this. Keeping food materials in airtight container. Okay? Yes or no? Shazan, Rudroniel, Rushil, yes or no?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, no? Yes. And one more thing, refrigeration of cooked food at low temperature.
But ma'am, refrigeration doesn't work for a long time.
It won't work for a longer time, but for 1 or 2 days we can. Yes?
There also, the food will not be that much fresh, like
It will not that much fresh. But we can keep at low temperature. And what is the third way to prevent this rancidity? Packing of food items like potato chips, potato wafers, like in packets containing the nitrogen gas instead of air, because nitrogen gas is an inert gas, and inert gas do not react chemically. See, here what's the third way? Packets containing the nitrogen gas instead of air, because nitrogen gas is an inert gas. And what is inert gas? Which do not react chemically. which do not react chemically. That's why in chips in the packet of Lay's, they fill the nitrogen gas because nitrogen gas is an inert gas and it will not react chemically with the
Ma'am,
other.
instead of hydrogen gas, what will happen if they put in helium?
See, if they'll put the normal gas instead of the nitrogen gas, then maybe they start reacting. Then maybe the outer metals, the outer water molecules start reacting with my chips. But the nitrogen gas is, if nitrogen gas is not reacting chemically, means it's acting as a barrier between the outside surrounding and the chips. N2 will act as a barrier with oxygen. It won't allow oxygen to come in contact with my chips. Okay, but helium will allow helium gas or any another gas. That's why they fill this 70% of nitrogen, 70% of gas with nitrogen and only 30% of chips is there because only the nitrogen will not allow the outside thing to react with my chips. Okay, okay, Shazan. And what's the fourth way? Avoid keeping the cooked food avoid keeping the cooked food materials in direct sunlight. Avoid keeping the cooked food in direct sunlight. In direct sunlight, there is a small microorganism present. That's why we avoid keeping our food directly come in contact with the sunlight. Okay, and by adding also antioxidant, we can prevent this rancidity by also adding antioxidants. And what is antioxidant? The example is BHA and BHT. What is BHA? Anybody? What is BHA and BHT? Nobody? See, the full form is hydroxyanisole. This term you guys will learn. Huh?
Ma'am, first one is
what?
Ma'am, can you tell how to pronounce it?
Which one? Acha, this one. But islated hydroxyanisole, and this one is hydroxy. Okay. This term you guys will learn in the higher classes. Okay, only you understand this, that by antioxidant we can prevent my rancidity. Okay, so this is the remaining topic of the first chapter, the corrosion and the rancidity. And my first chapter is completed. Next class I'll start with acid, bases, and salts. So this you guys understood. Can anyone explain me what is corrosion and what is rancidity? Come on, anybody. Shazan, Rushil, Rudronian. Anyone? Anybody? Okay, Shazan, you explain.
Oh, why, ma'am? Okay.
What? Why? This is easy now. And you are in 9th also, so explain it. Explain. What is corrosion?
It is a process in which metal gets rusted.
How?
Ma'am, due to atmosphere, ma'am, air and water is present in form of moisture that react with the metal, and it wants electron from metal, so it reacts with metal and it rusts, and the metal rusts. Okay.
Okay, good. Now next, Rudronian. Can you explain? Rudronian, am I audible? Okay, Rushil, can you? Okay, yeah.
What do I say?
What is corrosion and what is rancidity?
Corrosion is basically when the metal reacts with the water and the air, basically the humidity and the moisture.
And a metal is having which property?
Sorry, what?
Metal is having which property?
Iron.
Metal can
it donates electron.
It donates electron, and oxygen and water wants somebody to donate electron. That's why they react with metal, because metal is donating electron, and oxygen and water molecules want, so they come in contact with the metal and they form rust. That's the whole process is known as corrosion. Yes. Now, what is this? This is the copper. Copper turns into green because it will react with copper carbonate, and silver turns into black in color because of corrosion, because of the silver sulfide. And what is rancidity? Roshan, will you explain what is it?
Is the slow oxidation of food and food stuff then?
Yes. It's a what? It's the process of slow oxidation of
fat present in the food.
Yes. If we will keep our food for 1 or 2 days, then what will happen? The microorganisms start developing in our food surface. See here also my strawberry, and this is my apple, and this is my sandwich. Yes, so this is the process that microorganisms like fungus start developing. This is the process is known as the rancidity. Okay, how can we stop corrosion? I'll not show. Okay, one by one I'll ask. First, Shazan, how can we stop?
And by painting the metal, or ma'am, we can also coat it with zinc.
Yes, and that process is known as galvanization.
Yes,
yes, good. And now next, Rutronian, how can we stop?
Stop corrosion.
How can we stop corrosion? Any point?
By using an airtight
By
box.
using it?
Airtight box.
No, that's for rancidity.
Oh, for corrosion, you'll use a zinc, something with zinc.
Something with zinc, that galvanization, prevented by galvanization, zinc coating will do, hai na? Zinc coating will protect our metal from this corrosion. And what's the next point, Rushil? Here is the next point. What's the next point?
I'm not sure about the third point.
Okay, see, coating of the surface with iron, chromium, coating the surface with chromium, tin, nickel, and aluminium also can stop my metal from corrosion. And the last one is converting into an alloy. And what is alloy? Alloy is a mixture of two metals. Okay, and how can we stop rancidity, Shazan?
Yes, ma'am.
How can we stop rancidity? 1 point.
Ma'am, rancidity can be. Ma'am, yes, we can actually store the food in low temperature refrigeration process, ma'am.
Yes, good.
And one was like,
And one was?
ma'am, keeping the food in airtight containers.
Yes, very good. Keeping food materials in airtight container, just like here Lays also, hai na? It's airtightly bounded. Now, what's the next point? Rushil or Rudronian, anybody?
Ma'am, the food is kept away from direct sunlight.
Yes, very good. From direct sunlight. Why? Because in the sunlight also, if we will put our food direct contact with the sunlight, there are also small microorganisms present, and they will harm they can harm my food. Okay. And what's the next? Packet containing the nitrogen gas. This is the very important point, because nitrogen gas is also an inert gas. And what is inert gas? Which do not react chemically. That's why in Lays or any chips or any kurkure packet, they fill with 70% or 50% with nitrogen gas, because nitrogen gas will not react chemically, and any gas, they'll start react chemically. That's why we put nitrogen gas here. Okay, so this is the match. So this is all. And also the last point is by adding antioxidant and avoid keeping the cooked food in direct sunlight. So this is all about the corrosion and the rancidity. Okay, so here let's read one time. The phenomena due to which open surface of metals are slowly eaten away. That's what I wrote here. It's a slow process of eating away of metal with the reaction of what? With the reaction of atmospheric air and moisture, because in air there's a water molecule present in the form of humidity, which will react my metal, because metal is having a property of donating electron, and the water molecules and oxygen want the electron. That's why they come in contact with the metal. Okay, and if metal will not have this property of donating electron, then obviously corrosion will not happen, because the oxygen and water molecule want this. That's why the corrosion is happening. Now, what is metals are slowly eaten away by the reaction of air, water, and chemicals present in the atmosphere. This is known as corrosion. Example: iron articles are shiny when new, but get corroded with reddish brown powder. That's also a copper. Copper also. Where's copper? Copper. This is the silver. Yes. Sorry, the silver. Silver also turns into black after some 1 or 2 years. That's why our mother go to the shopkeeper, the jewelry shop, and what shopkeeper do? They'll take off the sulfide from the silver, and again silver will start shining. And what else? The process of corrosion of iron is known as rusting. Only the process of corrosion of iron is known as rusting, and the process of corrosion of this silver is known as this tarnishing of silver. And for all other metals, only we can say that this is a process of corrosion. We only for iron we use this word rusting, not for any other metals. The rusting of iron is a redox reaction. The black coating of silver, see, here is what? The black coating of silver, and I also wrote the silver black coating because of what? Because of the silver sulfide. And the green coating on copper. This is my copper, and here is the green coating on my copper. Okay, this is these are the examples of corrosion. Painting, galvanizing, electroplating are the methods to prevent corrosion. Here I wrote this much, the 1 or 2 and 3 and 4 points, that how we can prevent and how we can stop the corrosion. Okay, and what is the effects of corrosion? Corrosion can damage the car bodies, the bridges, the air railings, ships, and all objects made up of metals, especially which are made up of iron. Corrosion can damage to car bodies, bridges, iron railings, and this. Okay, corrosion is a wasteful process in most of the cases. Every year, tons of various metals, especially iron, gets wasted in a die country because of the corrosion. And what is rancidity? It's a process of slow oxidation of oil and fat present in the food material, resulting in the change of smell and taste in them. And how we can stop this? This is the process. Keeping food in airtight refrigeration potato wafers and avoiding in like with the direct sunlight. And this is the antioxidant. This is the example. This is the full form of DHA and DHT. Okay, everybody, done. This unit is completed. Understood? Everyone, Shazan, Roshil, Rudronial. Any doubt?
No, ma'am.
No?
Yes, ma'am.
Any doubt?
No, ma'am. Thank you, ma'am.